This next section will explore the topic of site drainage areas. What is a site drainage area, or SDA? It's an area that drains stormwater from a site to a single discharge point. In this context, sheet flow is considered to be one point of discharge. For most projects, it's based on the point of discharge from the lot boundary. For campus projects, it's based on the point of discharge from the limit of disturbance. Please note that projects in the MS4 have slightly different SDA requirements than projects in the combined sewer system. To help clarify, let's do an example. You've got a parcel of land with a lot boundary represented by this red box. For this example project, the limit of disturbance is outlined by this green dashed line. For the purpose of a stormwater management plan, this is the regulated area. Remember that a site drainage area is an area that drains to a single discharge point. Let's look at how water flows off this example project site. For a standard project, start at where the water discharges from the lot boundary and then work backwards. This will help you determine the site drainage areas within the limit of disturbance. For a campus project, you will create the site drainage areas based on where the water is discharged from the limit of disturbance. In this example, site drainage area 1 would then be subdivided into two smaller site drainage areas 1 and 5. Something to note. Notice that the whole area within the limit of disturbance is covered by SDAs. They do not overlap, they're distinct areas. In the next few slides, we'll be talking about how you enter the land cover for SDAs. Remember that we're only referring to land cover within the limit of disturbance, the regulated area. Now that we've set up the site and entered in some basic information about the project, it's time to add our site drainage areas. Click Add Site Drainage Area. This is the site drainage area form. With this form, you'll identify the pre- and post-project land cover for each site drainage area. SDAs are based on post-project drainage divides. We're going to look at two examples of this form since they vary slightly depending on if your project is located within the combined sewer system versus the separated MS4 system. This example is in the combined sewer system, as indicated by the yellow highlighted area. For the SGS to calculate how much stormwater will be retained when it falls on an SDA, we need to enter the type of ground cover. The main categories of land cover are natural, which is forests and meadows. These are not very common in the district. Compacted, which is grass and landscaped areas. Impervious, such as roads, driveways, walkways, and standard roofs. And then BMP, which is an area covered by a BMP. In this example, the pre-project land might have been a 5,000 square foot empty compacted lot that will be replaced with a 4,000 square foot building and a 1,000 square foot BMP. Final note, the total area pre and post project must match or you will not be able to save the page. Now, we're going to talk about SDAs in the MS4 area. Projects in the MS4 area are required to retain or treat, at a minimum, 50% of their stormwater retention value. This applies to each SDA, not just the whole parcel of land. In other words, you need to spread GI out across the site to manage the runoff from each SDA. You can't overbuild green infrastructure in one SDA and do nothing in another. Projects in the MS4, there's an additional requirement that applies to vehicular access areas, or VAA. This is an area used to park, drive, or work on vehicles. For these areas, 100% of the VAA must drain to a BMP, and it needs to retain or treat 50% of the stormwater retention value from the entire VAA. Let's look at an SDA form for a project being built in the MS4 area. Once again, as a reminder, here are those sewer coverage areas. The field highlighted in green indicated that we are not in the CSS but in the MS4. Because this site is in the MS4, a Vehicular Access Area column appears in the land cover section. This field is where you would enter the total square footage of area used to park, drive, or work on a vehicle. It is important to note that Vehicular Access Areas, or VAAs, is a component of impervious land cover. In this example, the Vehicular Access Area is the only impervious area in this project. This may seem like we're double counting. So let's take a second to understand how the SGS tallies the total for all land cover. The reason we need to break out the VAA from any other impervious surface area is that within the MS4 area, there are special requirements for how runoff from a VAA needs to be managed. This is due to the contamination that can result from vehicles being driven on a surface, think oil, gas, etc., and the fact that the MS4 stormwater drains directly into local waterways. As a final point, always remember that the pre and post project land areas must match. Once you've entered all the information for a site drainage area, the SGS will run the calculations and give you the stormwater retention volume, or SWRV. This factors in the size and the land cover of your SDAs, as well as the rain event your project needs to handle. In this case, since this is a major land disturbing project, it needs to handle a 1.2-inch rain event. Since this example is also located in the MS4, the SGS also provides the amount of treatment required for vehicular access areas. If this were located in the Anacostia Waterfront Development Zone, it would also present an additional value for water quality treatment, or WQTV, since the AWDZ has a water quality requirement. Again, this does not apply to most projects. If your project has another site drainage area, you can click here to begin entering another SDA. If you want to make any changes, you can click Edit to edit the page. Plan information form, you can see a summary of each site drainage area added to the plan under Land Cover and Site Drainage Area.